Welcome to Machine Learning Mayhem. Today, Rookie Data Dan faces the legendary Dr. Neuron in a laugh-out-loud job interview about supervised learning.
Professor Neuron, I'm here for the data scientist role. Excellent, Dan. Let's fire up the knowledge circuits. Ready for a hilarious grilling? I promise the only sparks will be from your brilliant mind. Gods. Bring on the supervised learning interview questions on fundamentals. Good. First up, what is supervised learning? And don't bore me with textbook definitions. Make me laugh.
It's when the model learns from labeled data to make predictions. Imagine teaching a dog to fetch the squeaky bone out of 100. That's supervised learning.
Classification predicts categories, regression predicts continuous values, classification sorts into boxes, regression draws the line, literally. Features are inputs, labels are outputs. Features are your ingredients, labels are the delicious cake. Don't mix them up.
It's the data used to train the model. The training set is where your model crams like it's finals week.
Used to evaluate how well the model generalizes. The test set sees if your model really learns something. When the model memorizes training data but performs poorly on new data. Overfitting is like memorizing jokes but not getting the punchline. Not funny. Underfitting is like trying to eat soup with a fork, utterly unsatisfying when the model is too simple to capture patterns. Cross-validation, meaning testing the model across multiple train test splits. Test your model on different friends like you're perfecting your spaghetti recipe. It's the balance between oversimplifying and overcomplicating a model. Balance that model like you're on a tightrope between simplicity and chaos. Elementary, my dear Dan. The decision tree is the Sherlock Holmes of algorithms, a flowchart model that splits based on features. Why have one detective when you can have a whole squad? That's random forest, bunch of decision trees combined for better results. Logistic for categories, linear for continuous numbers. Logistic regression shouts yes or no, while linear whispers a number. Parametric follows the recipe. Non-parametric gets creative in the kitchen. Parametric assumes a fixed structure. Non-parametric doesn't. Minimize those errors like you're skiing downhill to victory. Gradient descent, an optimization technique to reduce error. L1 and L2 regularization, reining in those wild weights, adds penalty to large weights to reduce overfitting. No feature should hog the spotlight. Time for some feature scaling. Normalizes feature values for fair comparison. Pick your features wisely, like drafting the best team for the big game. Feature selection is picking the most important features. Binary multi-class, multi-label is a classification party, like choosing Coke versus Pepsi or sorting every soda in the fridge. Is it action, comedy, or sci-fi? Multi-label says, why not all three? Predicting multiple labels for one input. Tell your model how bad it messed up, like telling your robot chef the soup is salty. Loss functions measure how wrong a prediction is. Accuracy, precision, recall. It's a cooking show for algorithms, evaluation metrics like judging a cooking contest, taste, style, creativity. Precision and recall, working together like Batman and Robin. F1 score is harmonic mean of precision and recall. Keep track of your model's wins and losses with the confusion matrix, a table of correct and incorrect predictions. 2 ways to judge a robot dual ROC and PR curves. ROC compares TPR versus FPR-PR, focuses on precision and recall. Stratified sampling ensures all classes are represented proportionally. Make sure every class gets an invite to the data party. Always taste the cake before you serve it. That's the 80-20 train test split. Divide data for training and testing, commonly 80-20th train test split strategy. Predict cookies, get cake. Cross-entropy measures that disappointment. Measures the difference between predicted and actual class probabilities. MSE squares those errors, May keeps it real. Choose your punishment wisely. Cat lovers on one side, dog lovers on the other. The decision boundary rules. Decision boundary in classification separates different class regions. One hot or label encoding, give your categorical variables a voice. One hot creates columns, label assigns numbers. Don't confuse the model. Give the underdog a fighting chance with resampling, SMOTE or class weights. Class imbalance solutions. Need more heroes? SMOTE clones the minority class to balance the fight. Finding the perfect hyperparameters is like brewing the perfect espresso. Hyperparameter tuning is optimizing model settings for best performance. Grid search tries everything, random search gets lucky. Pick your strategy. Grid tests all combos, random picks random sets. Don't overtrain. Know when to walk away like a poker champion. Early stopping means stop training when validation error increases.
Remember, overtraining can lead to poor performance on new data.
Not too fast, not too slow. Find that just right learning rate. Learning rate in gradient descent controls step size during updates. Epochs are full meals, batch sizes are snacks. Feed your model wisely. Epoch is full data pass, batch meaning mini updates. Online learning is streaming, batch learning is binge-watching lectures. Online learns continuously, batch processes all at once. Bigger isn't always better. Match complexity to your problem. Complexity affects what patterns the model can learn. One bad donut can ruin the batch. Handle those outliers. Remove or transform them depending on impact. Spice up your data with some feature engineering. It's the secret sauce. Creating new, useful input features. Clean, train, evaluate. The pipeline keeps your data flowing smoothly. Pipeline in Supervised ML combines pre-processing, training, and evaluation steps. Time to release your model into the wild, but watch out for those bugs. Model deployment is making the trained model available to users. Get your predictions fast with a REST API. It's the drive-through of AI. Lets users send input and get predictions via HTTP. Keep track of those model changes. You never know when you'll need to rewind. Version control for models keeps track of changes to models over time. Make your results reproducible, no hidden cards up your sleeve. Importance of reproducibility so others can replicate your result. Don't let your model run wild. Keep an eye on its performance. Model monitoring is tracking performance after deployment. Data drift is like a GPS that forgets where you are. Keep your data fresh. Data drift can make predictions less accurate. Here are some real-world applications of supervised learning. From spam filters to credit scoring, medical diagnosis, self-driving cars, supervised learning is everywhere. It's got labeled data and a prediction to make. Supervised learning's on the job.